This footage captures a high-velocity disc failure, where an angle grinder operating at 10,000 to 12,000 RPM released immense kinetic energy. Fragments were propelled outward like projectiles due to factors such as lateral pressure from binding or compromised disc integrity. The worker survived unscathed solely because of their PP. Since debris travels faster than human reaction time, the full face shield acted as the final barrier, absorbing an impact that would have otherwise caused severe trauma. This highlights the danger of operating in cramped spaces where the head is closer to the plane of rotation. It is critical to never remove the 180 safety guard or work without a shield. Safety protocols are not for the expected tasks but for the one in a million fluke. Complacency is the greatest risk. Staying protected ensures every routine workday ends safely. This footage provides a critical look at the mechanical risks associated with industrial rolling equipment. A primary factor in this incident was the lack of engineered safety barriers, such as fixed cages or light curtains, which are essential for separating personnel from in-running nip points. These rollers operate with immense torque. Once contact is made with a loose sleeve or glove, the mechanical force makes it impossible to resist the draw-in mechanism. This event highlights a failure in lockout, tagout, LOTO protocols, as manual adjustments were attempted while the machine was in motion. Furthermore, the absence of accessible emergency stop buttons led to a delayed response. Ultimately, this underscores the need for foolproof safety designs and a strong safety culture that prioritizes worker protection over productivity to prevent such life-altering consequences. This footage highlights critical failures in equipment setup and climbing technique, demonstrating that improper positioning is as dangerous as the height itself. The ladder was set at an unsafe angle, violating the 4-to-1 rule, which requires the base to be 1 foot away for every 4 feet of height. Furthermore, leaning the ladder against an unstable gutter caused a shift in the center of gravity as the worker ascended. Without a spotter or secured safety feet on the concrete surface, horizontal thrust from the worker's movements pushed the base out, leading to an immediate collapse. Standing on the top 3 rungs further compromised stability, as there was no secure handhold. This incident proves that familiarity leads to complacency. Even a short fall can be life-altering. Always perform a 4-point safety check and ensure a stable base before the first step. Thought. This technical analysis reveals that the primary failure was an incorrect prediction of the material's collapse path. During the manual demolition, a kickback effect occurred where the base of the wall snapped back toward the worker due to reactive ground force. Standing on a narrow ledge within the influence zone, which should be 1.5 times the structure's height, left the worker completely exposed. The sudden vibration and air pressure surge further destabilized his footing, leading to a secondary fall. This high-risk operation lacked essential fall protection, such as a full body harness and certified anchor point. Ultimately, this underscores that PP is not an invisible shield against structural collapse. Safety must prioritize hazard elimination through proper engineering and mechanical methods before relying on gear to mitigate the consequences of a risky maneuver. This incident highlights the critical importance of industrial safety standards through a technical analysis of several key factors. First, environmental hazards such as the lack of machine guarding and a congested workspace created high-risk pinch points and increased the likelihood of accidental contact. Regarding human factors, improper attire like loose-fitting clothing and a lapse in situational awareness allowed the high torque of the rotating shaft to snag the fabric instantly. The emergency response evaluation shows that a coworker's quick intervention and knowledge of the emergency stop location were decisive in preventing a worse outcome. To prevent future occurrences, engineering controls like interlocking guards, administrative exclusion zones, and rigorous hazard recognition training must be implemented. Adhering to these protocols ensures that machines and personnel remain safely separated. The industrial safety incident involving a pressure surge highlights critical systemic hazards and operational failures. The event likely stemmed from a rapid phase transition or chemical reaction upon material introduction, causing an instantaneous pressure spike that overwhelmed existing relief valves. A major contributing factor was the proximity of personnel to the danger zone. Workers were positioned in the line of fire without specialized PP like heat-resistant suits or face shields. The lack of reaction time and secondary containment allowed the substance to spread uncontrollably. To prevent recurrence, engineering controls, such as remote loading systems and interlocking lids, must be implemented. Additionally, strict standard operating procedures and accessible emergency showers are vital to ensuring a secure workplace and protecting personnel from high-risk thermal events. Thought. This technical analysis explores the mechanical and psychological factors of forklift tip-overs, emphasizing critical safety protocols for high-risk environments. Unlike cars, forklifts rely on a three-point suspension known as the stability triangle. Any shift in the combined center of gravity due to excessive height or uneven surfaces leads to an immediate tip-over. A dangerous salvage instinct often causes workers to attempt to manually stabilize the machine, a futile reflex given that the immense inertia of several tons of steel cannot be stopped by human force. Furthermore, the mast's sweep radius creates a wide danger zone, while operators in distress face significant blind spots. Ultimately, adhering to SOPs and ROPS compliant seatbelt use is vital. Ground personnel must be trained to prioritize their physical well-being over property, moving rapidly in the opposite direction when a tip-over begins. The technical failure of the high-bar apparatus serves as a critical case study in structural instability and insufficient load-bearing capacity. The equipment, mounted on an undersized frame without proper anchoring or guy wires, failed to dampen vibrations from high-velocity rotations. This led to a critical failure at the junction where the bar met the uprights, as centrifugal forces exceeded the strength of the fasteners. The incident occurred during peak dynamic loading, highlighting that the makeshift rig was not rated for extreme forces. Operating in such a high-hazard environment without redundant safety systems or buffers left the athlete vulnerable when the primary structure detached. To prevent such accidents, rigorous stress testing and strict redundancy protocols must be implemented, ensuring that mechanical integrity is prioritized over performance. This technical analysis examines the mechanical failures and operational risks of a tail lift and pallet jack incident, highlighting critical logistics safety standards. The engineering breakdown suggests the sudden drop resulted from hydraulic or cable system failure, where a loss of pressure or a snapped support cable created an immediate stability hazard. Furthermore, moving a pallet jack introduces a dynamic load that exceeds static weight limits, stressing hydraulic seals and triggering collapses. Human factors also played a role. The worker was positioned in a dangerous pinch zone between the equipment and the truck interior. Material handling standards prioritize pushing over pulling to maintain situational awareness and allow for a safe release during a tip-over. During the incident, an uneven lift created an inclined plane, causing the manual pallet jack to drift down the slope. Because of the high center of gravity, the cargo toppled in seconds. To prevent recurrence, SOPs must include pre-shift hydraulic inspections, ensuring the lift is fully leveled before crossing thresholds, and training personnel in the person over property principle to prioritize immediate evacuation over equipment salvage. This technical analysis examines the failures in load control and situational awareness during lifting operations, emphasizing the critical safety protocols required by industrial standards. The primary technical failure is the absence of tag lines, which allows a load to become a free-swinging pendulum that generates immense rotational torque. Once inertia takes over, attempting to stabilize the material by hand is physically impossible and hazardous. Furthermore, workers often violate line-of-fire protocols by standing within the swing radius, while operators may face blind spots during violent oscillations. Operational gaps, such as deficient risk assessments and a lack of exclusion zone management, further escalate these risks. To prevent such incidents, engineering controls must include sufficient guide ropes, while management enforces a zero-tolerance policy for improper rigging. Finally, comprehensive safety training is essential to ensure personnel never use their bodies to redirect moving mechanical loads.